All right, so in this video, I want to talk a little bit about the graphs of sine and of cosine and how those relate to the unit circle and why they look the way they do. And so the whole idea here is that we have the unit circle, which I've talked about in other videos. So make sure you know kind of what the unit circle is. And the unit circle starts right here and it rotates counterclockwise like this. And there's obviously a lot of points on the circle. There's an infinite number of different locations that you can reach. But really, I only care about four of those locations. And then I'm just going to make a sort of circular graph connecting those four locations. And so the points that I really care about are this one right here, which is 1 comma 0, this one here, 0 comma 1, this one here, negative 1 comma 0, and then 0 comma negative 1, and then we end here. Okay, and so we're basically just going to do the four compass directions: east, north, west, and south, and then back to east in that order. So the thing that I want you to keep in mind is that when we talk about graphing sine and cosine, what we're doing is paying attention to only one of our unit circle coordinates as we spin around the angles. So our angles here are 0 and then 2 pi makes a full circle. So half of 2 pi is 1 pi, half of that is pi over 2, halfway between pi and 2 pi is 3 pi over 2. You can think of it as 1.5 pi. And what I want you to notice is when I graph sine, what I'm actually going to graph is I'm going to graph y equals sine of theta. Now, a lot of times you end up typing in sine of x, but what I want you to interpret that as is at each angle on the unit circle, what is the y value at that point? So, for example, where we started was at an angle of 0. So when the angle is 0, what is the sine value? I completely ignore the x coordinate because the sine is the y coordinate. Okay? So what that means is angle 0, sine 0. That's why sine starts at the origin. When I go to the next angle of pi over 2, my sine value is 1. So at x equals pi over 2, I have a value of 1. I'm going to type that in as a point because I can't estimate pi over 2 extremely accurately. So I know my sine graph is going to go exactly through that point that I just typed in right there, because at the angle of pi over 2, the sine value is 1. The next angle that we're at is pi. At an angle of pi, what's the sine value? The sine value is 0. That. Next one, pointing due south, angle 3 pi over 2, sine value of negative 1. Turn that on. Back home at the beginning, which is also the end, 2 pi, comma, 0. Those are the points that I use to graph sine. I know that sine goes through a pattern where it goes 0, 1, 0, negative 1, 0. I like to think of sine as going middle, top, middle, bottom, and middle again, representing these 5 dots right here. And I can repeat that pattern because there's no limit on going around the circle. I can go around it a second time. Middle, top, middle, bottom, and then I run out of space. I can even go the other direction on the circle. I'm just going to run that pattern backwards. So I go bottom, right about there, middle, top, middle. Now I'm going to actually type in the equation, and I hope you can see why our equation looks the way it does. Because all I'm doing is telling the computer to rotate around the unit circle and hit what the y coordinate is on the unit circle at any given angle. That's what the graph of sine is. It's the y coordinates on the unit circle as you rotate counterclockwise. Now, if I switch my perspective, I'm going to delete all of these points here because that's sine. If I switch my perspective and instead of rotating around and looking at the y coordinates, let's look instead at cosine of theta. Now, this is a little bit weird because cosine talks about the x coordinates on the unit circle. But when I draw the graph of cosine, what I'm saying is y is equal to the x coordinate on the unit circle. And that can be really hard for students at first, but let's look at this equation again here. This equation is saying the y coordinate on the graph is equal to cosine the x coordinate on the unit circle. So I think sine is more straightforward because you're just lifting the y coordinate off the unit circle and putting it on the graph. Cosine is lifting the x coordinate off the unit circle and putting it on the graph. Okay. So let's go through the unit circle. Let's look at those sort of four corners again as we rotate around. When I'm at a 0-degree angle or a 0 radian angle, my cosine value is 1. I know my cosine graph is going to start with a y-intercept of 1 because that is the x-coordinate on the unit circle at the very first angle of 0. At the next angle, when I'm on the north end of the circle, angle pi over 2, cosine value is 0. So pi over 2 is about 1.5. That's going to be my next cosine value. At an angle of pi, my cosine value is -1, right about here. At an angle of 3 pi over 2, my cosine value is 0. 3 pi over 2 is going to be about 4.5. And when I get to my angle of 2 pi, I'm back at my cosine value of 1. It's just a little bit past 6. I'm going to be back up at a cosine value of 1. So just like how I took the y coordinates from a rotation to create the graph of sine, when I do a graph of cosine, I took the x coordinates on the unit circle and did a full rotation. Sine had a nice pattern where it went middle, top, middle, bottom, middle. The pattern for cosine is slightly different because the x coordinate is the biggest that it can possibly be at the start. So this is the top of the wave. 0, the x coordinate here, is the middle of the wave. -1 is the smallest x coordinate, bottom of the wave. 0 here, where you're right in the middle of the wave, and then back to the top. And so that's what I'm saying here, where we're top, middle, bottom, middle, top. That traces out a complete period of cosine because it's one rotation of the unit circle. Y equals cosine of x has the same shape as sine of x. The difference is where it starts. Rather than starting on the middle, like sine did, it starts at the top, and it repeats that same pattern, just shifted over by pi over 2 units. So that's the basics of graphing sine and cosine. Later, you start shifting and stretching them around. It's exactly the same as shifting and stretching any function, whether it's a quadratic or anything else. You just multiply, add, subtract, and it shifts it, stretches it, just like all the other functions. Okay, so let me know if you have any questions. Happy to help out.